Okay, welcome to another video. I've got my microphone on, so hopefully things are better than they were for most of the last video. We're going to be moving on to the second video in the multipath series. Hopefully there'll only be two. Right now I've only got about a half an hour, but by the end of the day, I'm hoping to finish this. So let's just jump right into it. So this is understanding configuration of up to 512 equal cost paths with optional consistent load balancing. You can configure the equal cost multipath ECMP feature with up to 512 paths for external BGP peers. Having the ability to configure up to 512 ECMP, which is so multipath, equal cost multipath next hops allows you to increase the number of direct BGP peer connections for your specified routing device, thus improving latency and optimizing data flow. You can optionally include consistent load balancing in that ECMP configuration. Consistent load balancing ensures that if an ECMP member, that is a path, fails, only flows flowing through that failed member are redistributed to other active ECMP members. Consistent load balancing also ensures that if an ECMP member is added, redistribution of flows from existing ECMP, which is EMPC? What the heck is that? I think it's just a typo. It's not worth a downvote. Redistribution of flows from existing EMPC, I think meaning ECMP, equal cost multipath members, to the new ECMP, equal cost multipath member, is minimal. Guidelines and limitations for configuring from 256 to 512 equal cost paths, ECMP, optionally with consistent load balancing. The feature applies only to single hop external BGP peers. This feature does not apply to MPLS routes. The device's routing process, RPD, must support 64-bit mode. 32-bit RPD is not supported. The feature applies only to unicast traffic. So traffic distribution might not be even across all group members. It depends on the traffic pattern and on the organization of the hashing flow set table in hardware. Consistent hashing minimizes remapping of flows to destination links when members are added to or deleted from the group. If you configure set forwarding options and enhanced hash key with one of the options, hash mode, INET, INET6, or layer 2, some flows might change destination links because the new hash parameters might generate new hash indexes for the flows, resulting in new destination links. To achieve the best possible hashing accuracy, this feature uses a cascaded topology to implement the next hop structure for configurations of more than 128 next hops. Hashing accuracy is therefore somewhat lesser than it is for ECMP equal cost multipath next hop configurations of less than 128, which do not require a cascaded topology. Existing flows on affected ECMP paths and new flows flowing over to those affected ECMP paths might switch paths during local route repair, and traffic skewing might be noticeable. However, any such skewing is corrected during the subsequent global route repair. When you increase the maximum in-cap value, consistency hashing is lost during the next hop change event for the route prefix. If you add a new path to an existing ECMP group, some flows over unaffected paths might move to the newly added path. Fast reroute, FRR, might not work with consistent hashing. Perfect ECMP equal cost multipath protocol like traffic distribution cannot be achieved. Paths have been more buckets than other paths have more traffic flows than paths with fewer buckets. A bucket is an entry in the load balancing table's distribution list that is mapped to an ECMP member index. During network topology change events, consistent hashing is lost for network prefixes in some instances because those prefixes point to a new ECMP next hop that does not have all properties of the prefix's previous ECMP next hops. If multiple network prefixes point to the same ECMP next hop and one or more of those prefixes is enabled with the consistent hash statement, all network prefixes pointing to that same ECMP next hop display consistent hashing behavior. Consistent hashing is supported on the equal cost BGP routes based ECMP group only. When other protocols or static routes are configured that have priority over BGP routes, consistent hashing is not supported. Consistent hashing might have limitations when the configuration is combined with configurations for the following features, because these features have tunnel terminations or traffic engineering that does not use hashing or selecting paths, GRE tunneling, bum traffic, EVPN, VXLAN, which is definitely going to be on the test. It looks like all of these are going to be on the test. GRE tunneling, that's going to be a part of infrastructure, I think. I'm actually not sure, but bum traffic, that's going to be a big part of VPNs, I believe, and it just means broadcast, unicast, multicast traffic, because each of those, it doesn't mean unicast, it means unknown unicast. Broadcast, unknown unicast, multicast traffic, because each of those can present a challenge where they either cause a straight up layer 2 broadcasting storm, so a loop of well, not necessarily a loop, but a flood of traffic, like too much traffic, like they could just flood the link. It's a broadcast storm, so it just congests the whole network and shuts down. And then, so broadcast have traffic, obviously, yeah, that can do that. Unknown unicast. So the reason unknown unicast is a problem is because when it gets to a switch, if it doesn't know and unknown is talking about the destination MAC address. If it doesn't know the destination MAC address, it will flood it out every port on the switch except the port it came in on. So if you constantly have that flooding information, that can cause problems too. And then of course, multicast, same thing, but it's just not going to be as severe. So it's kind of ordered in terms of severity: broadcast, unknown unicast, multicast. But for bum traffic, they require special considerations because of the potential risks and dangers they could have for the network. One really great thing you can do that I think is really important for a lot of networks is to set up a broadcast storm method thing to limit, like if you're receiving 5% of your bandwidth utilization is just broadcast address, you can, or broadcast frames, you can set up a policy to say, I'm not going to accept any more broadcast frames. I'm not going to send any more broadcast frames. There's a storm happening, so I'm going to take protective measures to prevent this from being too big of a problem. And not only that, I'm going to send syslog messages, at a reasonable rate, saying to the owner of this, hey, you've got to fix this. There's a storm. If you didn't set up these protections, thank goodness you did, because the whole network would be down now. You can have that scenario instead of the scenario where the whole network is down. So that kind of ties really closely into our theme here. Lessen your failures, impactless failure, impactful success. So the kind of failure we want in the case of a broadcast storm is a percentage of our bandwidth being in the trash and us to be alerted that something is going on. We don't want the kind of failure where all of our bandwidth is in the trash. We don't even get an alert until we come in the next day and see that the network's not working, or somebody, customer calls you in the middle of the night. You want to be alerted through your own detection systems, and you want the impact to be minimal. So minimal, in fact, that you don't even have to get up in the middle of the night and fix it. It's like, oh, okay, well, 2% of my bandwidth is now utilized for this stupid problem. Okay, I'll go in and fix it later, or I'll schedule a maintenance when it was more convenient for me. So that's kind of an impactless failure, by just having a policy set up that says, hey, here's a problem. Hey, here's how I'm handling that problem. Hey, you need to fix it, instead of, oh God, everything's on fire, do something now. So they're both failures. They're both problems, but one is a very impactful problem, very impactful failure. The other one is impactless, and that's what we want. That is the main theme of this channel. I'm hoping this is kind of really valuable for anyone who might be watching this too, because I know from firsthand experience, there's a lot of real world scenarios where this is not something that's considered, and in fact, it's kind of, there's antagonistic attitudes towards it, because employees would be considered less productive, or be considered that they're not as serious or not as professional because they're not constantly putting out really serious issues. Well, if you had been what I would consider more professional, more adept, more skilled, yeah, like if you can saw off your own arm, if you can do your own, take the harpoon out of your chest, do your own stitches, yeah, that's really skilled. I'd be impressed. But I wouldn't expect the average person to have those skills. I would expect them to be more adept in avoiding such severe injury, which, if you think about it, is a little bit of a skill itself. Like, why would you just walk off the edge of a cliff and fall to your death? Like, I would consider not jumping off a cliff without a parachute or bungee cord or something like that to be a skill. So hopefully this is valuable to somebody besides me. And then I consider myself an evangelizer for these concepts for these running themes. When I say they're running themes, I don't mean they're just kind of weekly help beliefs. These are my core fundamental tenets that will spout to anyone I work with professionally. Concepts, not commands. Look before you leap. So that's just general here and now workplace safety, doing the extra, show pipe compare, having things prepared in a notepad, looking it over instead of just on the command line, making sure you're on the right device, basic, simple stuff. You'll hear about that anyway. That's kind of basic stuff. But the kind that's kind of more unique to me that you won't necessarily hear in environments. In fact, you might hear the opposite, because engineers might be given more respect for constantly putting out fires. And, that's when people are going to get a appreciation reward, or some kind of reward, is when, they did something stupid and did a heroic effort to resolve that. All that is seen is the heroic effort, not the why did you do that, or why didn't you do that. That is generally not as socially acceptable to express frustration and concern over. It's more socially acceptable to express, at least in the professional experience I've had, I have seen that this lessen your failures has in fact been greaten your failures in a lot of cases. But this is why this is probably, I almost kind of want to put this up on number one. Yeah, I'm going to move this up. I mean, they're not in order necessarily, but I'm definitely going to, I don't think it's quite number one because concepts, not commands, is just really important. And you couldn't lessen your failures if you didn't know the concepts. So, yeah, so hopefully that's clear. If it's not clear, let me know in the comments and I'll do a whole video on it. I might just make another line that just says running themes and just go through each running theme and be very clear about what I mean and kind of show real world examples of how you would be violating the routing theme and how you would be living it out to the fullest. But for now, as you can notice, I get very easily distracted. So I want to make sure that I'm good to go for this test because that's what this series is all about. It's not necessarily about real world professional experience. Instructions for configuring up to 512 ECMP next hops and optionally configuring consistent load balancing. When you are ready to configure up to 512 next hops, use the following configuration instructions. Configure the maximum number of ECMP next hops. For example, configure 512 ECMP next hops. Create a routing policy and enable per packet load balancing, thus enabling ECMP globally on the system. Enable resiliency on selected prefixes by creating a separate routing policy to match incoming routes to one or more destination prefixes. Apply an eBGP import policy to the group of BGP group external peers. So I think we have this in our help. So I'm going to pull that up and I'm going to do a help pipe match C hash and hopefully we'll see everything here. So let's see here, group. There we go. So help reference. And then this is for BGP multipath. Perfect. And then it's going to be pipe match C hash. So, okay, this is interesting. I don't see anything specifically there. I don't think it's reference. I'm still kind of trying to figure out the difference between all of the approprios. I don't even know what approprios means. I've never even heard that term outside of Juniper. With reference to, concerning. Okay, so that's a pretty appropriate word, but I don't understand how that's different from help reference. Okay, so let's see if we can get help for this section. Oh, pipe match. Nope. Okay, so we don't have any specific help for a C hash. For more detail on cost equal paths, see example, load balancing. Aha, and we just did that one last video, so we won't need to see that. Configuring consistent load balancing. This one we might want to add because, oh, for aggregated Ethernet interfaces. Yeah, I don't know. I'm going to skip that one. I'm thinking things won't be. They're not going to go into the absolute insane, wild details on the test. There's just not enough time. I mean, maybe they will, but I mean, you can see like I've already spent probably over 1,000 minutes just on like one topic, just on like 2 topics so far. So it's like they want to test you on every little thing. An 8-hour test, believe it or not, might be a little bit too short. Okay, so yeah, let's move on to the example. Configuring single hop eBGP peers to accept remote next hops. I am going to just save this. Yep, because it might be, no, it's this one I'm going to save. Yep. It just might be useful, and it might help us to better understand this concept as a whole. All right, but focusing on this overview, in some situations, it is necessary to configure a single hop eBGP peer to accept a remote next hop with which it does not share a common subnet. The default behavior for any single hop address received from a single hop eBGP peer is that it is not recognized as sharing a is not. The default behavior for any next hop address received from a single eBGP peer that is not recognized as sharing a common subnet is to be discarded. And we saw this before. This is the one I had to ask my coworker about, and he said I've got to include the multi-hop knob, and I included that, and it worked. The ability to have a single hop eBGP peer accept a remote next hop to which it is not directly connected also prevents you from having to configure the single hop eBGP neighbor as a multi-hop session. When you configure a multi-hop session in this situation, all next hop routes learned through this eBGP peer are labeled indirect, even when they do share a common subnet. This situation breaks multipath functionality for routes that are recursively resolved over routes that include these next hop addresses. Configuring the accept remote next hop statement allows a single hop eBGP peer to accept a remote next hop, which restores multipath functionality for routes that are resolved over these next hop addresses. You can configure this statement at the global, group, or neighbor hierarchy levels for BGP. This statement is also supported on logical systems and the VPN routing and forwarding, VRF routing instance type. Both the remote next hop and the eBGP peer must support BGP route refresh as defined in RFC 2918, route refresh capability in BGP version 4. If the remote peer does not support BGP route refresh, the session is reset. When you enable a single hop eBGP peer to accept a remote next hop, you must also configure an import routing policy on the eBGP peer that specifies the remote next hop address. In this example includes an import policy, egg route, that enables a single hop external BGP device R1, to accept the remote next hop 1.1.10.10 for the route 1.1.230.0/23 network at the edit protocols BGP hierarchy level. The example includes the import ag route to apply the policy to the external peer and includes the accept remote next hop statement to enable the next hop BGP peer to accept the remote next hop. Okay, so it looks like the topology is going to be a little bit different. So I'll need to put that around. I don't want to go past 8. So I'm going to take a moment here and switch over to the subnetting practice. I think I can do that in 7 minutes. So I'm going to do 5 correct. Yep, so already we got an easy one. It's going to be 255. So that's 8 bits. So to get to 12 bits, we're going to need 4 more bits. So 4 bits on is 240.0.0. So 4 more. Last valid host, so 172.22.153. And now it's going to be 219 is going to have 2 bits on to represent 192, but we can't turn this one up because that would bring us all the way up to 224. And that's the 32-bit, but we can turn on the 16-bit and get to 208. So if we're at 208, we just need 11 more. So we need to represent 11. So that's going to be up, but we can stop here because we know that the line is going to be here. So we know it's going to be 254. We're not going to need to toggle. We're not going to need to worry about the bits in the network portion, whether they are 1 or 0s, because we could see in the last octet they were just all 1s. So turning them on in the network host portion is going to give us a value of 255. The last valid host is going to be 254. All right, time for 3 more. The valid host range for a network that the IP 10.83.6.3.131/26 is a part of. So this is the first host and the last host. It's /26, so we know the first 3 octets are going to be unchanged. So we only need to think about the last octet. A /26 is going to have the divider line here. So we're going to need to represent 131. So 131, we just have, /26 is going to be every 64. We'll separate the subnets, and then we're just going to have 1 on. So all 0s, this is going to be easy. It's going to be 128 for the network, so 129 for the first host. And then since it's a /26, it's just going to be 64 higher than 128 is going to be the next network address. So 128 plus 4, that's going to give us a 2. 128, 678, so 192 is going to be the next one. So it's going to be 191, 190. Oh. Let me look at the answer for this. Oh, God damn it. I'm going to count that one as right for now and just do 2 more. Well, I'm just going to do 1 more because I'm almost out. I mean, I got it right. It's just typing error. All right, so first valid host. This one looks like it might be one of the easier ones. So it's going to be 248. So that's going to be every 8 addresses. So 0, 8, 16, 24, 32. So this falls into the 24 through 33 subnet. So the first valid host is going to be 25. Correct. So I think I'm going to stop about 3 minutes early there. I'm kind of tempted to do 1 more, but I don't want to go over time. So Thanks for watching, and stay tuned for the next video where we, since we finish the reading, we'll just dive right into the configuration of single hop eBGP peers to accept remote next hops.